Welcome back to the Geometry textbook series. This lesson is written based on Chapter 3, Section 1, the distance formula. In today's lesson, we're going to learn how to state and apply the distance formula. Before we start the lesson, you should know how to simplify radical expressions and how to apply the Pythagorean theorem. You're also going to learn the following new words: origin, axes, and quadrants. You might already know those. Let's warm up first by finding some distances on a horizontal number line. Pause the video and restart when you're ready to see the answers. I will show them now. Okay, how did this go? Now this is an important skill that we're going to use throughout the lesson, so if you struggled with this, make sure to go back and review before you start. Let's review some terms that you remember probably from primary school in coordinate geometry. The origin is the point 0, 0, usually denoted with the letter O. The x-axis is a horizontal line that passes through the origin, and its positive direction is to the right. The y-axis is a vertical line that passes through the origin, and its positive direction is up. The quadrants are the four regions formed by the intersection of the axes, and they're labeled 1 to 4 using Roman numerals, starting in quadrant 1 and moving counterclockwise until you reach quadrant 4. Finally, the plane of the x-axis and the y-axis is called the coordinate plane. Now, how much of that do you remember? So let's suppose we need to find the distance between two pairs of points. Now, if you know how to do this, pause the video and restart when you're ready to see the answers. I'll show my answers in 3, 2, 1, now. Okay, A and B lie on a horizontal line. So the distance between A and B is the difference in their x-coordinates, which is 3 minus -1, the absolute value of 3 minus -1, which is 4. C and D lie on a vertical line, so that the distance between C and D is the difference between their y-coordinates, which is 1 minus -2, which equals 3. In example 1, we need to find the distance between point A, which is at 4, -2, and point B, which is at 1, 2. I'm going to start by just drawing the line segment AB. Okay. Next, we can draw our line segments to form a right triangle. Let's call it ATB. Now we're going to calculate the length of each leg. And now we're ready to use, that's right, the Pythagorean theorem. So let's go ahead and plug everything in. So AT squared plus TB squared equals AB squared. I'm going to plug in AT equals 3 and TB equals 4. I'm going to simplify. I'll take the square root and I get that AB is equal to 5. So we can find the distance between 2 points using the Pythagorean theorem, but we can also use a general formula. If you're looking for the proof, it's going to be featured in our Not How But Why series. I'll put a link to that below, but let's just move on to the formula. So the formula can be generalized as follows. The distance d between 2 points x1, y1 and x2, y2 is given by d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, a couple of things. Number one, notice that the order of the coordinates can be switched because we're squaring each one. And this is really just our change in x and our change in y. So it looks a little bit like slope, kind of. So now what I'd love for you to do is take the formula that we just learned and try it with example number 2, where we need to find the distance between -4, 2 and 2, -1. Okay, I'm going to start my answer in 3, 2, 1, now. First, I'm going to identify my coordinates. X1 is 4, X1 is -4, Y1 is 2, X2 is 2, and Y2 is -1. Now, I'm going to substitute them into the distance formula. Pretty simple from here. I'm just going to simplify underneath my radical. And I get to square root of 45, which is 3 radical 5. Usually the hardest part is just identifying the coordinates. Once you get that, you plug it into the formula and you're usually okay. Now, for my second example, I need to find the equation of a circle with a center of 5, 6 and a radius of 4. So first I'm going to draw my point 5, 6. Okay, Now, I'm going to say that point PXY is any point on the circle. Okay, we don't know the coordinates of it, we're just using a generic XY. Since the radius is 4, the distance from 5, 6 to PXY is also 4. So we can use the distance formula. We're going to substitute in D equals 4, X1 equals 1, and Y1 equals 6. And now, all we do is we square both sides to get 16 equals X minus 5 squared plus Y minus 6 squared. Now, just keep in mind, both of these equations, the bottom two equations, are acceptable answers. They're both equations of a circle. However, the second one is most commonly used, and we're going to see that in our next slide, which goes through the theorem. The formal theorem is as follows. An equation of a circle centered at the point AB with a radius of r is x minus a squared plus y minus b squared equals r squared. In this book, AB is used for the coordinates of the center, but keep in mind that other books, most other textbooks, the coordinates of the center are HK. All right, and I believe we have one more example before we're done. We need to find the center and radius of a circle with the equation x minus 1 squared plus y plus 2 squared equals 9. Now, you may be able to pluck the values out, but generally I find it's helpful to rewrite the equation in the form provided in the theorem and pull out the relevant information. So I can rewrite this equation as x minus 1 squared plus y minus negative 2 squared equals 3 squared. Then I can very easily see that my center is at 1, negative 2, and my radius is 3. Okay, hopefully that wasn't too much. You guys did an excellent job today. You are probably distance formula experts, and I know you're going to have no trouble finding the equation of the circle in the future. Now, before you go, turn to your classmate and show what you know by answering the question. What is the most popular way to represent the coordinates of a center of a circle? That should say center. And I will see you in the next video.